Question number 4 says that express the numbers appearing in the following statements in the standard form. A number when expressed in standard form is a product of a number that lies between 1.0 to 10.0 including 1.0 and a power of 10. The power of 10 can be anything depending upon the position of the decimal. Now to get a number into the standard form, we will have to shift the position of the decimal. So if the decimal is shifted towards left, the power of 10 gets added. And if the decimal is shifted towards right, the power of 10 gets subtracted. So going by this thumb rule, we'll start solving each of the parts. We'll take the first part, part A. It says that the distance between Earth and Moon is this given large number. So this can be currently written as decimal being after the last 0 that we have times 10 raised to 0. Because anything raised to 0 is 1. Now the decimal should be moved between 3 and 8 so that we get a number 3.8 which lies in this range. So let's see by how many places do we have to move the decimal. 1, 2, 3, 4, 5, 6, 7 and 8. So we can then write it as 3.84 times 10 raised to 0 plus the number by which we have moved the decimal. So in this case it was 8. So we add 0 and 8 and the answer that we get is 8, which is the power of 10. So 3.84 times 10 raised to 8 meters is the distance between Earth and Moon in standard form. Coming to the part B, we have been given with the speed of light in vacuum. So we will follow the same steps that we had followed in part A. We'll keep a decimal here and we times it with 0. And the decimal is to be moved between 3 and 0. And if we count by how many places do we have to move the decimal towards left, it is 8. So we can write it as 3 times 10 raised to 8 meter per second, which is the speed of light in vacuum in standard form. In part C, we have been given with the diameter of Earth, which is this large number. We again keep the decimal after the last digit, which is 0. We times the number with 10 raised to 0. The decimal has to be between 1 and 2. We'll have to move the decimal towards left. And the number of places by which we have to move the decimal towards left is 7. So our answer will be 1.2756 times 10 raised to 7 meters. And this is the standard form of the diameter of Earth. Now coming to the part D, which is the diameter of the Sun, we have to get the decimal between 1 and 4. The decimal is currently after the last digit, which is 0. We have to move the decimal towards left by 9 places. So our answer will be 1.4 times 10 raised to 9 meters. This is the diameter of Sun in the standard form. We'll go on to the next set of bits given in the same question. Part E gives us that in a galaxy there are on an average so many stars. So this number is to be converted into the standard form so that it becomes easier for us to read it out. The decimal, which is currently here after the last 0, should be moved between 1 and 0. So the decimal moves towards left by 11 places. So the answer will be 1 times 10 raised to 11. So this is the number of stars that we have in a galaxy on an average. Coming to the part F, it says the universe is estimated to be about this large number years old. Again, we'll try to get the decimal, which is currently here between 1.2, so that we get the number 1.2. So the number of places by which we have to move the decimal towards left is 10. So the answer will be 1.2 times 10 raised to 10 years old. So this is the standard form of the age of the universe. That is, the universe is 1.2 times 10 raised to 10 years old. Coming to part G, it says that the distance of the Sun from the center of the Milky Way galaxy is estimated to be such a huge number in meters. The decimal is here. We'll count by how many places do we have to move the decimal towards left so that it is between 3 and 0. So on counting, we will get the answer as 20. That is, the decimal is to be moved towards left by 20 places. So the answer will be 3 times 10 raised to 20 meters, which is a standard form of the distance given, which is between the Sun and the Milky Way galaxy, the center of the Milky Way galaxy. We come to the part H now. This huge number of molecules are contained in a drop of water weighing 1.8 gram. So we'll have to convert this into standard form so that it becomes easier for us to read it out. Otherwise, this huge number would be very, very difficult for us to read out. The decimal, which is currently here, should be moved between 6 and 0. On counting, we get that number as 22. That is, the decimal should be shifted by 22 places towards left. So our answer will be 6.023 times 10 raised to 22 molecules. We'll move on to the last two bits of the same question. Part I says that the earth has so many cubic kilometer of seawater. We'll convert the number into standard form by getting the decimal between 1 and 3. So taking it from this position towards left by 9 places will give us the standard form of the number given in this statement. So that will be 1.353 times 10 raised to 9 cubic kilometer. Coming to the last part of this question, which is part J, it says that the population of India was about so many people in March in 2001. We'll have to get the decimal between 1 and 0 to get it into the standard form. So the decimal moves by 9 places from this position, which is after the last 0 that we have, towards left. So the answer will be 1.027 times 10 raised to 9. So this is the standard form of the population of India, which was there in the month of March in 2001. And this is how we can get any huge or large number into the standard form so that it becomes easier for us to compare, to read, and to understand how large is a certain number.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.